Fantastic. Thank you. Thank you, Janice and Tony, for putting this together. And thank you for inviting me to speak on two of my favorite topics, AI and data. Data has been a favorite topic of mine for quite some time. AI is certainly a newer one. I will say before we get started here, just looking at the material to cover and the time we have, I'm going to ask that we save questions till the end. I'm going to try and save some time at the end to address any questions that there are. But I would encourage you as we go through, if you have questions, put them in the chat. That way you don't forget them, and that way, we have those queued up when we get to the Q&A portion. So, as Janice said, my name is Scott Yates. I'm a director in the strategic consulting group with Woolpert, which is an architectural engineering and geospatial firm. My focus is on asset management, asset information systems, and digital transformation across the entire asset lifecycle. I've got 20 plus years experience in asset management. As Janice mentioned, I'm the data chair for the airports working group with buildingSMART USA. And I will say right off the bat here, I do not consider myself to be any sort of leading AI expert. My background is in asset management and asset information and asset information systems. However, I've spent, over the last 2, 3 years, I've spent every free available moment, hour I have studying everything I can about artificial intelligence, just because I truly believe in the transformative nature of it and that it's going to completely reshape, our industry over the next decade. And so I want to make sure, that I'm at the forefront of that and leveraging that to the benefit of the owners that I work with to help them build strategies on how to incorporate it. And so this presentation is going to be, about some of the things I've learned about AI and some of the insights that, I've come up with when I pair that learning with my experience in asset management and data. So, all right. So today we're going to talk a little bit. I am going to do kind of an introduction to AI, very brief, not super detailed. Just enough to level set what we're going to be talking about through the presentation. I do want to talk a little bit about AI in the AEC industry specifically, so you can see the context of why this is a relevant conversation. And then really we're going to get into the meat of what I want to talk about today, which is the role that data plays in artificial intelligence, some of the data management considerations that we all should be considering as we embark on this new age of artificial intelligence, and all of that, with an eye towards building trust in the use of artificial intelligence in our organizations and in our project teams. So, beginning with an introduction to AI, once again, very brief one, I asked ChatGPT, great AI tool, to give me a definition of artificial intelligence. And this is what it came up with. It said artificial intelligence refers to the development of computer systems that mimic human intelligence, such as visual perception, speech recognition, decision making, and language translation. Now, that's a pretty good definition. But what I find, why I wanted to put this up and what I find interesting about this is, if any of you went and asked it the same question, it's highly unlikely that you would get the exact same answer. However, you would certainly get a very similar answer. And I would be willing to bet that the answer I got is right and the answer that you got is right. And also, as you look on the slide here, I also followed up with, okay, whose definition is that? Where did you get that from? And ChatGPT was able to give me kind of an explanation of how it came up with the definition that it provided to me. So it had taken sources that it had been trained on and synthesized an answer to give to me in response to my prompt. And what I find, particularly interesting about that is it's one of the things that has kind of been a light bulb moment for me as it relates to AI. It really reasons like a human, and so it kind of shifted my mindset as I look at artificial intelligence and the application of artificial intelligence, and it's kind of moving me away from thinking of it as a software product and thinking about the adoption and implementation of AI, purely as a software product, and really got me starting to think about AI like I think about people and like I think about human resources within my own organization. Kind of continuing the introduction to AI here, machines are not just tools. They are now teammates, and they're reshaping how we interact with technology, and it's a true game changer for the industry. Now, the mind shift for me of thinking about AI, as just like a human resource, or more so like a human resource than a software application. I don't say that to say that AI is going to replace all our people and all our employees. I honestly, we've been hearing arguments like that for technologies since I've been in the industry, going as far back as some of the early mobile projects that I worked on. There was always a fear that the introduction of technology was going to reduce the available jobs that were out there. And I don't look at AI that way. I look at AI as a force multiplier. I look at it from the perspective of wanting to take the best employees that I have in my organization and clone them, not for the purposes of replacing them, but for the purposes of increasing their bandwidth, increasing the scalability of my organization. I look at it like taking my best employee or my good employees and giving them 5 additional employees that are free, that are just as capable or close to as capable as they are. So, it's a force multiplier that allows us to scale capability without significantly increasing cost. And that's where, for companies that adopt it, I think it's a true game changer. At the end of the day, it's about growth, not contraction. Okay. So I do want to make a distinction between, what I consider to be everyday AI versus game-changing AI. I think this is important as we look at the application of AI within our organizations and teams. Everyday AI is, the things like ChatGPT, the things like Gemini that we just use on our own, typically to, make repetitive, mundane, administrative tasks easier. Just make things that we have to do every day a little bit less effort, a little bit less time consuming, a little bit easier. And these use cases are becoming incredibly pervasive. And I want to separate that from the definition of game changing AI, where I look at game changing AI as where we have really analyzed the things within our business, within our company, that differentiate us, the true value we provide as an organization related to our services, related to our solutions, related to our experience, and investing in AI to be able to infuse AI with those unique things that differentiate us and use it as the force multiplier that I talked about to really be able to significantly scale the things that we're already good at and do them at an even higher volume, at an increased speed, and at an increased capability. And so, one of the reasons why I make that distinction, this is going to come back around as we get later in the presentation and talk about security. I think our security stance as it relates to AI needs to fit in alignment with this definition of everyday AI versus game-changing AI as well. All right, so let's take a look at the impact of AI on the AEC industry specifically. And I'll start off by just reading this quote from McKinsey. The global construction industry is expected to invest heavily in AI startups and the adoption of cloud-based technologies, generating $8 billion in revenue from the sector through 2031. And in addition to that, AI use cases in construction have more than doubled from 20% in 2017 to 50% in 2022 among businesses that use AI in at least one area. And so, as I think about this, I recall a book I read recently that I highly recommend to all of you out there. It's called Digital Transformation: Survive and Thrive in an Era of Mass Extinction. And it was written by Thomas M. Siebel, who's a legendary billionaire technologist. But he basically states the premise that with the capabilities that AI brings, companies that don't go all in and invest in AI are simply not going to survive in the long term, period. And the more I'm exposed to artificial intelligence, it's not an overnight thing, but it's coming quicker than we think. I agree with that. I think companies that do not have an AI strategy are not looking to embed their secret sauce into artificial intelligent models are going to find it very difficult to compete in the marketplaces that they compete in. The other thing that I think is very interesting about, the information you have in front of you right now is the qualifier where it says among businesses that use AI in at least one area, right? So we see this significant increase in adoption, expansion, and use from the companies that have already dipped their toe in it. And I just contrast that against all of the articles we see out there these days of the high percentage of failures in large enterprise application implementations. It seems like as we look at enterprise application implementations across our organizations, those are becoming harder and harder to successfully execute, whereas the success rate we're seeing with concerted, heavily invested AI efforts is going in the opposite direction, and they tend to be far more successful. And I think what that means is in the long run, we're going to see a significant shift in how we utilize IT infrastructure within our organizations, and it's going to have a huge impact in the role of enterprise, currently off-the-shelf branded enterprise applications versus the use of artificial intelligence, and kind of changes the game on how we have to look at our IT infrastructure strategy and place more of a focus on data management, right? Common data environments, more of a focus on training and developing AI models that are aligned with our business, as well as, going out on the market and finding, really valuable solution-based AI models that have been developed by others as well. But I do believe it's going to have a significant impact on how we look at our IT stack within our organizations. And it's something that can't be ignored. So, facing all of this, how can AEC firms stay competitive, efficient, and innovative? AEC itself is evolving rapidly as the technology evolves. With every wave of technology, more and more of our organizational and industry intelligence is becoming, and experience is becoming embedded in the digital products that we create, along with the physical work and physical deliverables, the facilities, the systems that we deliver to our customers. And so, in that vein, I think all AEC companies need to at least partially start thinking like technology companies and have an element of being a technology company. The line between the physical and virtual worlds is certainly starting to blur. And I think we're quickly finding ourselves in a place where delivering the virtual products on our projects are becoming almost as important as the physical facilities and systems that we're delivering themselves. And so this is something that certainly needs to stay, at the forefront of your mind. As we look across, the various phases of the asset lifecycle that we all get involved in, I did want to just kind of point out some examples of where we're seeing artificial intelligence already being applied and some of the real value-added use cases that are out there. This is certainly not an exhaustive list. This is just kind of meant to give some examples of some of the things we're seeing. And so, when we look in the design phase, we're talking largely about AI-powered design optimization. Just looking at the sheer amount of compute power we have available to us and the intelligence that we can build into these AI models, it gives us the ability to better retain project history, data from previous projects, and apply that through models to do an endless number of design simulations, which give us the ability to predict how different designs will perform in real world scenarios based on what we've seen in the past, what other organizations have seen in the past, and other knowledge sharing content that that is available out there. Just the ability to call on that experience in a second's notice, and the ability to compute that large amount of data in such a short period of time makes this an incredibly interesting tool as it relates to design. So being able to perform design simulations at scale quickly and very detailed, being able to do design validation on our designs, again, quickly at scale. And then even to the point of being able to do generative design, where we're asking the AI model to actually produce based on some parameters or rules that we give it, data that we give it, requirements for a project, produce optimized designs that are generated faster and aligned with project constraints. And really, as you look at this, again, it just comes back to the sheer horsepower and volume. I can ask an AI to come up with an optimal design based on some parameters, and it's producing thousands, if not more than that, results, in a matter of seconds or minutes, and scoring those results, grabbing the most promising ones and putting that back in front of you. Just the sheer volume of what it's able to compute, puts it at an advantage versus a human designer. And again, I don't say that to say that we would replace human designers, but I'd say that to say that we put tools like this in the hands of human designers to be an exponential force multiplier for them. As we transition into the build phase of the asset lifecycle, some of what we're seeing here as far as the use of AI, data-driven project management, and AI being used for automation. So some of the examples you see here is data strategy, developing a real-time data collection system, having the ability to, in real time, use photogrammetry or LiDAR sensors to collect data in real time and use that for a number of purposes. Use that to automate activities like inspections, material handling. I mean, even to automate construction equipment that is performing some of the work. Use it to enhance our quality control. So using data from sensors and cameras to detect potential construction errors or where we're behind schedule. I mean, these are things that are already happening out on the marketplace, leveraging artificial intelligence. And once again, you can see that aspect of it being a time saver, of it being a force multiplier, and in most cases of it being far more accurate than humanly performed tasks as well. Continuing on through the asset lifecycle, looking at the operate phase. And so here, the use of AI in this space, I believe is highlighted by leveraging digital twins, one of the hottest terms out there, certainly in our industry. I was at the NIBS Digital Twins conference yesterday in DC. But using digital twins, integrating virtual models with IoT sensor data and static data, and pairing that with AI models to monitor and predict performance and plan appropriate responses both in operations and in maintenance. Now, this particular area is near and dear to my heart based on my background in enterprise asset management and maintenance work management. So for years, I've been helping organizations try and optimize proactive maintenance programs, limited to what is essentially three levers in most of our enterprise asset management systems. Frequency, let's maintain something on a static frequency, usage level, or condition monitoring, and and typically just one specific condition monitoring point to drive or trigger a maintenance activity. But AI-enabled digital twins that can aggregate and interpret data from countless variables, history, context, condition, performance, the weather, whatever it may be, are exponentially more accurate in predicting potential failure than our assumption-laden basic levers that we've used in the past. And so, this goes beyond just being able to improve reliability, but which is the best that we could hope for to optimize in a manual environment, to actually fine-tuning the maintenance to specific desired levels of performance for a system or facility. And so, the kind of the analogy I give is this is the equivalent of moving from a control panel with three analog buttons to a control panel that has 10, 50, 100 knobs. And oh, by the way, those knobs know when to turn themselves based on the objectives that you fed it. So complete game changer in this space. As we move into the maintenance phase of the asset life cycle and looking at the latter years of the assets in our facilities, and building on the digital twin example from the previous slide, what's been a traditional asset management challenge is synchronizing the links between day-to-day work management and maintenance that we do to improve the reliability of facilities, and link that back to our overarching capital improvement plans, capital renewal plans, and design of new facilities. Those things have always been traditionally very disconnected in organizations for a lot of reasons, departmental silos and disconnections, but certainly information system disconnections and silos is another thing that feeds into that. And so, what we're seeing with AI is much more of a capability to link those systems together and determine the impact and do things like say, okay, if I modify my maintenance on this particular system, let's say I increase the maintenance level, increase my maintenance spend, what's the impact on my prognosis for when I would need to renew this thing or replace this thing, and vice versa. When I'm designing a facility, the design decisions that I make, what is the impact on the maintenance investment I would need to make to be able to maintain that facility or that system at the performance levels that I want. So being able to connect those worlds through artificial intelligence, develop, interpretations of the relationships between what's happening on both sides of that fence is, again, immensely powerful and solves something that has been a significant challenge in the industry for quite some time. Okay, so that's just kind of, again, just kind of looking at some of the ways AI is being applied across the entire asset lifecycle. Yesterday I mentioned I was at the Digital Twins conference. I saw countless more use cases of where AI-infused technologies and models are just solving very real problems that we have across our industry. But what I want to talk about now and get into a little bit is the role of data in AI, because I really think, the paradigm shift in our industry towards AI-driven solutions really puts all of us even more at the forefront of being data stewards and needing to be effective managers of data, because that is the lifeblood of AI systems. And so just kind of wanted to look, I think probably many of you or most of you are familiar with some of these basics, and this is certainly a 30,000 foot view, but I just wanted to point out, both the way we train and use an AI model. So most basic building blocks of training an AI model, we're starting with a set of rules that the model has on how it interprets data, and we're giving it a set of data to learn on, right? And then we're asking it questions. We're interrogating it and saying, okay, based on the rules that you have and based on the data that I'm giving you, answer my question. And then we validate that answer. We score it on whether it was a good, bad, and really spectrum in between answer. And the model then learns and adjusts based on that feedback that it's getting. So it continues to get more sophisticated with the rules that it has. But keep in mind, the only thing that it knows is the data that it's been given up front, and the feedback or the data that is getting along the way, and the feedback that we're giving to it as we do kind of this testing cycle. And so data is a huge driver and element around the quote unquote intelligence that this model is going to have. If I have a very limited, poor quality set of data that I'm training my model on, that's really all it's going to know. And that's going to limit the quality of the results it's capable of giving you. So data plays a huge role in the sophistication and success of an AI model. But even when you kind of switch gears into using an AI model that someone else has developed and handed off to you, the inputs to that are the question that you're asking, the prompt, as well as the data that is either embedded in your prompt or given along with it, or that you're providing as a knowledge base to the AI model. So you're basically saying to the AI model, take everything you already know and the criteria that you've developed that you have refined over time that provide successful outputs, and now look at my data and use your reasoning, your rules to provide the output that I'm asking for based on my data. So even in the use of an AI model, there is again an injection of data. And so data, the success of an output of using even an already trained, really good AI model is limited by the quality of the data that you're feeding in when you're interrogating that model. And so, one of the things I like to say is that data in this day and age is destiny. The data that we're feeding into these AI models is absolutely driving the impact, the value, the success that we see out the back end. And really, technology has changed the speed and scale of these data-driven decisions. These models are entirely dependent on the data which they are trained or that they're being fed as we use them. So good data matters more than ever. And that the graphic you see there is simply stating, if I've got garbage data, I mean, it's the age-old thing in IT. If I've got garbage data going in, even if my model is fantastic, my AI model is, state of the art, I'm still going to get a garbage result because I'm giving it garbage data through the front end. An analogy I like to use here is one of my favorite Simpsons episodes. Homer Simpson changes his name to Max Power. And he says, from now on, there's going to be three ways to do things: the right way, the wrong way, and the Max Power way. And Bart Simpson says, well, isn't that just the wrong way again? And he goes, yeah, but faster. And that's an important concept to keep in mind. Simply applying new technology without thought to the care and feeding of the data that you're putting into these systems is actually incredibly problematic, because not only are you going to get bad results, but now you're going to get bad results at the speed of light. Right. And that's going to cause just even bigger problems. And so data is a critical element in how we train these AI models and how we use these AI models. And the data we want to use is everywhere. It's everything. As we look across design, construction, maintenance, operations, it's literally everything we can get our hands on that we use as humans to plan things out, to make decisions, to do analysis. All of that information is the information that is the type of things that we would want to be feeding into the AI models that we're training. So whether we're talking about master plans at the very beginning of planning and that information, BIM models from design, takeoff schedules from constructions, reality capture scans that we're getting as we execute construction, safety incidents that are occurring through operations. If I can bring all of these data elements together inside the AI models that I'm using, they have the ability to draw from those experiences and make decisions just like your best employee does. It's exactly how those employees operate. And so the management and curation and integration of this data becomes one of your most important activities, one of your most important fundamentals. All right. So if data management is so important in leveraging and using AI, what do we need to keep our eye on? What do we need to consider from a data management perspective if we want to leverage AI? And so we absolutely want to look towards having better data governance in place in our organization, right? So data governance is the process of managing the availability, the usability, the integrity, and the security of data across our entire organization. It involves defining policies and procedures for how we're going to access data, how we're going to use data, how we're going to store data, how we're going to share data. And ultimately, data governance ensures that the data that we use in our AI models is accurate, consistent, and reliable, which is absolutely critical to being able to leverage AI. I mean, it's critical to your employees today. And so it would follow on that it is certainly critical to how we develop and train AI models. Now, so why, what are some of the benefits? Why is data governance important? Well, it's important because we ensure that the data is managed effectively and efficiently. It sets the guidelines for data quality in our organization, for data privacy, for security, for regulatory compliance. And all of these elements are incredibly important to the use of artificial intelligence models. Without good data governance, our organizations are at significant risk of having poor data quality feeding their decisions, of having data breaches into their IP, and of having even potentially legal and regulatory impacts as we continue to use more and more AI inside our organization. So, what are some of the best practices around data governance? Well, first and foremost, we want to establish a data governance framework as well as data policies and standards. And so, this is about documenting, literally getting down on paper, a clear policy and plan. And it may also involve organizational changes as well. You may develop new roles and responsibilities within an organization to ensure that your data governance is being executed properly. An example I give, something that I'm doing very much right now for a number of clients, is creating enterprise asset data management plans. And so what we're doing in these documents is we're mapping critical data flows, starting out from the stakeholder using the data, often in enterprise systems. So we're looking at the data standards and schemas associated with specific enterprise systems or even departmental level spreadsheets. And we're tracing those things back to their origin and mapping every step along the way. And we're putting processes and organizational structure in place that allows us to most efficiently control that flow of data from start to finish. And the resulting impact is a clear and an efficient plan on how you create data, acquire data, generate data, manage data, and disseminate data across your enterprise. And really, this becomes the foundation to all of your IT projects and initiatives. And so some of the key questions you want to answer as you go into establishing your data governance practices are: what data is critical, right? Interviewing your stakeholders, what data is most critical to them? Who uses it and how do they use it? Where does that data come from? What is the definition of quality as it relates to that data? What makes that particular type of data good versus bad? Are there any privacy or security concerns as it relates to that type of data? What is that impact and how can we control that? So just some of the things as an organization we should be thinking through and mapping through to get effective data governance in place. And as you can imagine, all those things I just mentioned, this is a document or a policy that once you establish it would continue to live and grow with the organization, as you change the way you operate or expand your use of certain systems. All right. So, with all that in mind, how do we start to build more trust in AI, in machine learning? Well, we talk about data governance, we talk about data management. There are some areas we really should be focused on when we're working within the realm of artificial intelligence. First and foremost, I've kind of already been hammering this nail, but I'll reiterate it once again. We should be aiming to improve our data quality. And I'm going to talk in a minute about what my definition, high level definition of data quality is, but we should be focused on implementing processes, tools, organizational responsibilities that ultimately drive an improvement in our overall data quality across our enterprise. We also, and these are some of the ones that are very unique to AI, we should be looking to reduce bias in our AI models. And again, I'm going to talk in a second about what bias is and what impact that has, but it certainly should be a focus of our data management strategies. And then finally, increasing transparency in artificial intelligence and how we're using artificial intelligence. And I'm going to hit in a little bit more detail on that topic as well. So looking at the first item, data quality issues. And so this is where I like to give the term that I've coined in this space, which is the 4 A's of data quality. If you've seen me present before, you may have heard me use this term before, but the 4 A's of data quality. Abundance. We need to have enough data to support the type of decisions that we're making, right? If we're particularly when we're looking at things that are forecasts or probabilistic, the more data we have, the better. The more criteria, the more nuance in criteria that an AI model is going to be able to develop as it reviews that data and as it answers questions about that data. So, having enough data is certainly a core data quality element. The next one is accuracy, right? Obviously, I mean, we want the data to be right if we are going to use it to drive decisions. So another measure of the quality of my data is how accurate is the data that I have, no matter what type of data that I'm talking about. Another one that may not always come up, in traditional definitions of data quality, but I certainly believe in this day and age of, system interoperability and data interoperability, and our more expanded view across the asset lifecycle. I think this is a huge element as it relates to data quality, and that's accessibility. It doesn't really matter if I have a ton of data and if it's good, accurate data, if the people who need it can't get to it, right, for the decisions that they need to make. And this is one of the biggest challenges, that we're facing and attempting to directly address as we look at promoting open standards, and promoting VDC BIM based methodologies in planning, designing, constructing, and operating facilities. A lot of what we're targeting is data accessibility. And so I think that's an important factor as we look at data quality. And then the final A in our 4 A's of data quality is ASAP, as soon as possible. And that's meant to represent timeliness. So not only does that data need to be accessible, but it needs to be accessible at the right time to the right people when that critical decision is being made. So as we look at data governance and data management, considerations, plans, when we look at data quality specifically, these are absolutely the measures we should be focusing on to assure that we have, high data quality feeding wherever we're using artificial intelligence. The next item I had mentioned that we should be focused on is bias in AI. And so bias in AI occurs when an algorithm produces results that systematically favor one outcome over another. And this can happen for several reasons. There's actually again, I'll give you another recommendation. There's a fantastic documentary on Netflix called Coded Bias. And it really dives deep into this topic and talks about, and the use case they give is around computer vision doing facial recognition and the bias that often exists based on race and gender, depending on how a particular computer vision model has been trained. But that same concept applies to any type of data. I mean, it could absolutely be a bias towards an extreme overreaction to failure indicators when we're looking at historical data to predict failures, right? If we have fed it only extreme situations, then it is likely to be biased towards predicting extreme outcomes. So again, highly recommend checking out that documentary and then thinking about how that could apply to the types of data that you have in your organization, and processes. Basically the concept there is if all I see are nails, then of course my solution is always going to be a hammer. It's taking that tried and true concept and very much applies as we look at AI models. Some of the types of bias that we see in AI models. One is representation bias, and so this is purely about data sampling and based on the data that we're making available to the model. If it's skewed in one particular direction, representing one particular aspect of what we're concerned about, then obviously the model is going to be weighted towards that. But another one is algorithmic bias. And so this is where the construction of the underlying criteria and rule set itself already has an inherent bias built into it. And so it's like the equivalent of asking the wrong question right from the beginning or overemphasizing certain rules in how that question gets interpreted and a result gets gets produced, that the latter, so algorithmic transparency or algorithmic bias, is something that can certainly be influenced based on the manner of how the model is trained and the feedback, the human loop feedback that it's getting in scoring its results. One of the ways that can manifest itself. So the main message here is that these things are real. If we're trusting AI to reason and make these types of decisions, and they've been trained on a data set, then it's important that we understand this concept of potential bias in the data. One thing I'll qualify though here, I mean, we do the same thing as humans, right? If we're trained on a certain type of data, that's exactly how we develop, kind of rote answers or stereotypes that we get. So this isn't anything new, but when we're kind of handing off the trust to a computer, it becomes, I think, much more elevated and prevalent, and again, is happening at a much bigger, larger, and faster scale. And so it's always been important, but it becomes even more important in this particular context. So when you're adopting AI within your organization, you've got to consider means and methods, so processes and tools for being able to both detect bias as well as mitigate the bias that you have in your models. And then the final, data management consideration for garnering trust in AI that I had presented was transparency, as well as in kind of expanding transparency into explainability as well. So a huge part of addressing the issues on the previous slides is by elevating the importance of model transparency and model explainability. So think about, I think about when you're trying to help your kids with their math homework, right? And they don't want to show their work. So they've gotten the right answer, but they didn't show their work. And you're, trying to tell them that they need to show their work. The teacher's going to be expecting them to show their work, and they're frustrated because they got the right answer. It's the same situation here. The reason why we want our children, in this case, to share their work or show their work is because we want to ensure that they know the method for getting at the right answer, not just that they stumbled upon it or got lucky with it. And if they can show their work and show that they followed the right process, then we can have a certain level of confidence that when we give them a new problem, which is similar, they're going to get the right answer there too, because they know the way to get to it. This exact same concept applies with AI models, and which is why model transparency and explainability is so important. Like we have to make our AI models show their work to a certain extent. And so just these terms, they may be new to you. Model transparency refers to the degree with which the inner workings of the model are open and understandable to humans. It involves making the model's structure, parameters, and function visible, right? So actually exposing how the model operates. Model explainability is about making the decisions of an AI model understandable to humans. And so it focuses on providing clear and accessible explanations for why a model made a particular decision. I point you back towards, one of the first slides I presented where we asked ChatGPT the definition of artificial intelligence and then asked how it came up with this answer. That is an example of model explainability, allowing it to explain how it actually got to the answers that it provided to you. And I think it's an important concept that we all keep in mind as we use AI. And then the final item you see there is data provenance. As have I been stating all along, and have hopefully made the case about the influence and importance that data has on both our training and use of AI models. So data provenance becomes a huge part of that. And so this involves understanding what data has been used to train a model, what its origin is, what its source is, what its history is, so that you can make judgments around the validity of the use of that data in what you're trying to accomplish with a particular model. I mean, I think we can all I think we can all think about situations where, stuff we've seen out on the internet, right? There are certainly questionable sources of data out there. And if our AI models are interpreting that with the same level of value, that stuff we have validated and provided, then that obviously can put us in a pretty precarious situation. So understanding data provenance of the data that's going into your AI models is hugely important as well. Kind of the final category I want to talk about as it relates to the use of AI relates to security and privacy. So, AI, machine learning, it's capable of collecting and processing large amounts of both company sensitive data and personal data about individuals. And so, obviously, this can raise significant security and privacy concerns. I think this is one of the biggest challenges that organizations are struggling with right now. You need to have a careful thought and clear strategy around the AI tools that you're using, and whether, really whether they're okay to use. And where they're okay to use. And so, just to provide, another real life example, my company has completely locked down the use of any AI tools that are not provided to us by or vetted by our own IT department. And so for us right now, as far as default availability of AI, that's primarily Microsoft Copilot through Office 365. Literally any other use of AI for business use or on our business machines have to be cleared through IT. And so, of course, we're doing targeted internal projects with AI throughout the organization, but these are all being executed under scrutiny from AI from IT, where they can ensure that the data, our company sensitive data, our intellectual property, our secret sauce is being protected. And that's twofold. So, not that it just can be taken and used by other organizations that may have access to the data we're feeding into, these public models, but also, to the fact that we could be making one of those public models very good at what we are good at and how we differentiate ourselves. And that certainly minimizes our opportunity to capitalize on that capability. So these are very real concerns that need to be addressed. But as far as addressing it, I think a lot of companies are maybe being overly conservative as it relates to that. Certainly, other companies aren't looking at it at all, and I think both those extremes can cause problems. But this is where I want to tie back to the concept I had earlier of game-changing AI versus everyday AI. In general, I think an intelligent risk-based strategy around this would allow for some level of freedom in the case of the use of everyday AI, as long as employees are being educated and trained on the proper use, what to be concerned with, how to protect private data and company sensitive data. I think there should be, slightly wider guardrails in that space. Whereas the game changing AI, where we're taking our secret sauce and we're training AI models on it, those should be secured at all costs. Because again, going back to some of the statements I made earlier in the presentation, I believe that represents the future, even down to the future viability of the company. And it's important that you have controls in place to protect that. Now, of course, in developing these strategies, there are mechanisms for securing artificial intelligence, based on where the models are hosted, firewalls that are put in place. There's tools out there that allow for the anonymization of data, the encryption of data. So, there's a whole market out there growing of, tools that can be utilized to help manage kind of these two different realms of the use of AI in an organization. I guess the main lesson here is that to understand, you want to understand the implications of the types of AI you're using, and then you want to align in a risk-based strategy the appropriate steps to protect yourself based on that usage. It's not going to be an all or one application. All right, final thoughts here from the presentation, kind of wrapping things up. I think you've probably heard from me some of the passion I have in this space. AI is coming. It's here, and it's continuing to grow. And it truly is transformative for the companies that are using it appropriately and investing in it appropriately. But as you venture down this path, data is critical to the effective and safe use of AI. And so data management has to become a mission critical strategy within every organization. And so data governance and management are more important than they ever have been. Someone like me is going to argue they've always been important, but certainly even more so now in this new day and age. Final thing I'll leave you with, always like to leave a little nugget from who I've kind of adopted as my life coach, Ted Lasso. There are two buttons I never like to hit. That's the panic and the snooze, right? So the message here is, you're not too late to the game. It's not too late to start. No need to hit the panic button, but at the same time, I wouldn't put off AI considerations much farther, because the ability to compete within the markets we compete in is going to become more and more challenging, as more and more companies really do leverage artificial intelligence, and you certainly don't want to be left behind.